Hello class, welcome back to XY Lecture 101. So in this video, I'm going to discuss or explain the differences between mass and weight. So it sounds like an easy topic, but some of the students do not know the differences between mass and weight. So please listen attentively so that after watching this video, you can able to differentiate between mass and weight. So let's begin with mass. So what is mass? So mass, it is the property of matter. So it means that the mass of an object is measured. It is measured of the amount of the matter in the object. And then the mass of an object is the same everywhere. So mass doesn't change according to the location. Like for example, my mass is 65 kilograms. So wherever I go, if I'm going to Mars, Jupiter, Saturn, or the Moon, my mass will remain constant. It will remain constant. It's still 65 kilograms. Another mass, it is scalar quantity. Again, it is scalar quantity. It means that it has magnitude. And then mass can be measured using ordinary balance, like for example the beam balance. Excuse me. And then mass, the unit for mass is grams or kilograms. So we're done with the definitions or the difference of mass from weight. And then let's proceed to the weight. So weight, it is defined as the force of the gravity on the object. It means that weight varies, depends on the effect of the gravity on the object. And then weight varies according to the location. According to the location, it means that weight is not constant. It is not constant. It is changing. Like for example, my weight here in the earth is 637 Newton. So where did I get that? Or how did I get that? Or how did I get that weight? So this is the formula for weight. So weight of the object is equal to the mass of an object times or multiply to the acceleration of gravity. Again, weight of an object is equal to the mass of an object times acceleration of gravity, or W is equal to M times G. And then M stands for mass of an object, and then G stands for acceleration gravity. And always remember that the acceleration gravity in the earth is about 9.8 meter per second squared. So for you to able to compute or to get your weight, just multiply your mass to the acceleration of the gravity. So my mass is 65 kilograms. So therefore 65 kilograms times 9.8 meter per second squared is equal to 637 kilogram meter per second squared or newtons. So that is my weight in the earth. I mentioned earlier that weight is not constant or varies according to the location. If my weight in the earth is 637 newtons, if I'm going to the Mars, my weight will be decreased. Why? Because the acceleration gravity in the Mars is lower than the acceleration gravity in the Earth. And then the acceleration gravity in the Mars is about 3.7 meter per second squared. So therefore, we are going to get my weight if I'm going to Mars. So 65 times 3.7 meter per second. So therefore, my weight in the Mars is 240.5. So my weight decreased. So my weight in the Earth is 637, while my weight in the Mars is 240.5 newtons. Another location, if I'm going to the moon, the acceleration of gravity in the moon is 1.6 meter per second squared. So I'm going to compute my weight in the moon. So 65 kilograms times 1.6 meter per second squared is equal to 104. So 104 newtons or kilogram meter per seconds. So that is my weight in the moon. So let's summarize again. If I'm in the Earth, my weight is 637 newtons. And then if I'm in the Mars, my weight is 240.5, and in the moon, my weight is 104 newtons. So it means that weight is unconstant, or it is not constant. It is changing based on the location and based on the amount of acceleration gravity of a certain planet or place. So another weight is a vector quantity. It is a vector quantity. It means that it has both magnitude and direction, because gravity, it is directed towards the center of the earth. And then weight can be measured by using a spring balance. And then the units for weight, it's either kilogram meter per second squared or newton. Again, kilogram meter per second or newton. Or some industries, like for example engineering, they are using kilogram force as the unit of weight. Again, kilogram force as the unit of weight. And in 1 kilogram force, there is 9.8 newtons. Again, in 1 kilogram force, there is 9.8 newtons. What if you are going to convert your weight into found force? So just times your weight, like for example, my weight in the earth is 637 newtons times 0.224,809 is equal to 143 pounds force. So that is my conversion from weight to pounds or pound force. So we're done with the differences of mass and weight. Okay, to make it clear, mass is constant while weight is constant. It means it is changing according to the location. And if you're going to solve some problems involving about weight and mass, you can know the computation or the unit that you are going to use in your problems. Like for example, if the variable is mass, you are going to use kilogram or grams, and then if the variables is weight, you are going to use Newton or kilogram force or kilogram meter per second. So please, if you are filing some documents and then you are going to fill up the weight, so please do the same process. So in order to get your weight, just multiply your mass and then to the gravity or acceleration gravity of the earth. I hope you understand, and I hope you learn a lot from this discussion. Or if you have any comments or suggestions, or if you want to suggest topic to be discussed in this channel, please comment below. Do not forget to subscribe and hit the notification bell so that you will be updated on my next video. So thank you for watching.